Okay, this video is to help you if you're at home and you're working through the reflections slide. Okay, I'm basically going over the answers, but make sure you understand what you're doing in your slides. Okay, a reflection is a flip. Okay, yesterday we did translations. Translations were slides. Okay, reflections are flips. Okay, you're either flipping over the x-axis or the y-axis. At least that's what we're going to do. We're going to keep it to just those two lines. Okay, the x-axis and the y-axis, those are considered the lines of reflection. Okay, and what we get is called a mirror image. Okay, this is an original four-sided shape, quadrilateral. It's flipped over the x-axis. Okay, over here, the same is flipped over the y-axis. Okay, if we had paper, you could actually take the shape and flip it over. Okay, on the next slide, I wanted you guys to drag over, are they x-axis reflections or y-axis reflections? Okay, just remember the x-axis goes straight across. So that problem right there is an x-axis reflection because it's flipped over the x-axis, which goes across. This last one, okay, the y-axis is the line that goes up and down. Okay, this one is flipped over the y-axis. Okay, so you can work through those. Okay, just like with translations, there's some things that are true. Okay, remember we talked about side lengths and angles and things like that. Okay, let's look at this problem right here. If I have a rectangle ABCD and I flip it over the y-axis, okay, I get A prime, B prime, C prime, D prime. Okay, can you tell that you get the same exact shape? Okay, so they're both similar and congruent. Okay, the line segments are the same shape. Okay, the pre-image segments and the new segments. For example, AB is 1 and A prime B prime is 1. Okay, they're both one space. Okay, you can tell the angles stay the same. Okay, you started with 90-degree angles in all four angles, and you ended up with all 90-degree angles. Okay, we also notice that parallel lines in the original shape remain parallel when you flip it. Okay, so try that next slide. Before you look at my answers, try it, okay? Okay, in this problem, this quadrilateral is reflected over the x-axis, okay, the straight across axis. Okay, count the side lengths to determine if they remained equivalent. Sorry, I left off my T. Okay, CD is 4 units. C prime D prime is 4 units. Okay, the side lengths stay the same. Okay, does it look like the angle measures remain the same after it's flipped? Okay, yes. And these parallel lines, A, B, and CD, they remained parallel when we flipped it. Okay, so just important things to keep in mind. Okay, we're going to look at what happens to points and what happens to the pictures when we flip, when we reflect. Okay, in class, we're going to play on this this GeoGebra link. So you may want to do that. It's kind of fun. But here's some problems we're looking at what happens to the spacing and what happens to the actual coordinates. Okay, so let's say we had pentagon ABCDE up here. Okay, I left off my E. Okay, it's really ABCDE. Okay, if I reflected over the x-axis, okay, and I used the link before to do it. Okay, if I reflected it over the x-axis, notice some things about the points. A is 4 spaces above the x-axis. A prime is 4 spaces below. B is 2 spaces above. B prime is 2 spaces below it. Okay, C is 2 spaces above the x-axis. C prime is 2 spaces below. Get the idea? When you have a reflection over the x-axis, If you have a point above the x-axis, the reflection is below it. The same distance away, but below it. Okay, and the same is true as if you started out below the x-axis and you flipped it, you would notice it's going to be above the x-axis, that same distance. Some of the stuff, it's going to get a lot easier after you practice some of these on Khan Academy, okay? But that's the general gist. If we look at the coordinates of the original shape compared to the coordinates of the reflection, I want you to notice what happens. Like A is 0.14. A prime ended up being 1, -4. Okay, point B is 0.12. B prime is 0.1, -2. So after you fill in all of these coordinates, I want you to see that the x coordinate stayed the same every time, but the y coordinate changed. Okay, you see that? Like 1, 2 to 1, -2. The x coordinates stayed the same. The y coordinate changed. So we could say the rule is that xy maps to x -y or opposite y. Okay? That's the shortcut. Same reasoning for reflections over the y-axis. Okay, if you look at a shape like ABCDE, if I reflect it over the y-axis, you're going to notice every time a point is to the right so many spaces, the reflection is going to be the same distance to the left. Okay, so you could go with those point by point. I'm just trying to save time on the video. You would see that when you have a pre-image reflected over the y-axis, okay, if a point is to the right of the y-axis, the image point is the same distance to the left of the y-axis. Okay, now we're thinking right-left instead of up-down like we did before. If the pre-image point is to the left of the y-axis, the image point is that same distance to the right of the y-axis. Okay, and again, you'll get used to this as you work on some problems on Khan Academy and Delta Math, but I just want you to get the gist of it. Okay, the next slide. If we look at the coordinates of that same flip, okay, if I label the coordinates of points A, B, C, D, and E, and A prime, B prime, C prime, D prime, and E prime, okay, you're going to notice this time, if you look at A and A prime just for a second, A is 1, 4. A prime is -1, 4. See, in these problems, the x coordinates change sign. The y coordinate stayed the same. So the rule for a y-axis flip, y-axis reflection, x, y maps to -x, y. Okay, that's just a shortcut way of showing you that the x coordinate changes sign and the y coordinate stays the same. Okay, next slide. They're showing you two shapes. They want you to know that that top one is not a reflection. It's just a slide. It's a slide 7 down. It's not reflected, but the bottom one is a reflection. The next slide, what they're giving you is an original shape, ABC, triangle ABC. They want you to reflect it over the y-axis. If it was reflected over the y-axis, where would the triangle be located? Okay, I gave you some little points to drag because I'm a visual person. I like to see it. If I had paper, I'd be sketching this out. Okay, so if I had triangle ABC and I reflected it over the y-axis, okay, A is one space above. I'm sorry, one space to the left. A prime would be one space to the right. C is one space above. C prime would be one space to the right. Okay, B is, I believe, 5. B is 5 spaces to the left of the y-axis. B prime would be 5 spaces right. Okay, so then you could figure out what those coordinates are. Okay, if you reflect over the x-axis instead, okay, the horizontal x-axis, now you're going to think, instead of right and left, you're thinking up and down. Okay, so if C is 2 spaces above, C prime is 2 spaces down. B is 2 spaces above, so B prime would be 2 spaces down. Okay, A is 5 spaces above. A prime would be 5 spaces down below. Okay, you can figure out the coordinates after you get an idea of where they would be. Okay, next problem is just like it. I'll let you work through it. Work through it and then check the answers. But just remember, if a line's reflected over the x-axis, it's the same distance away from your x-axis. It just changes the side, like up versus down. If it's reflected over your y-axis, the reflection points are the same distance away from your y-axis, but it's just right versus left. Okay, so a way to think of it is opposite direction from your line of reflection, but the same distance away. Okay, the next one, last slide. I'm just giving you the points. I'm just giving you the points of a shape, triangle ABC. I want to know just what are the coordinates of the y-axis reflection. So all you have to know is that when you do a y-axis reflection, the x coordinates change and the y coordinates stay the same. So the 7 and the 4 and the -1 become a -7, a -4, and a +1. Okay, but the y values stay the same. So 9, 3, and 5 stay the same. Okay, if you reflect over the x-axis, okay, the y coordinates change signs. They all change signs. And the x coordinates stay the same. So you could figure out which points those are. Okay, guys, I hurried. I don't like to spend much time on these videos because I know they take a lot of time, and I don't think we are getting as much out of those. But please let me know if I went too fast, if I'm not making sense, because I do want to help you if you are having trouble understanding anything. Okay?